All right, folks, welcome back from spring break. Uh, and we're going to go ahead and resume our discussion here. So everything is still pretty much on schedule here. I think my target for this semester, given that it's mostly going to be online, was that those five modules basically. And we're pretty much done with three. And now that we are post spring break, we're going to have two more. And that's pretty much it. So that would basically be your grade for the semester, and the last two, and then the last one sort of like is a two-parter, I suppose. Uh, this sort of continuation of EDM, which is now the generalized equilibrium displacement model, is probably going to be even more challenging than what the EDM was. So what I want you to do, of course, is you absolutely have to watch the video, right? So you cannot just wing the questions. I I would strongly encourage you to watch the video and then attempt the sort of homework. So without further ado, let's go ahead and dive straight into it. What I want to do is just do a bit of a review as well for what the equilibrium displacement model was. And the idea basically is that we are trying to understand, suppose there are sudden changes in the market. So suppose there are sudden changes in the supply or there is a demand problem. So these days, for instance, I am looking at some research in sort of like the Ohio, Pennsylvania area, where there may be certain issues associated with carbon intensities. And as you know, a lot of ethanol producers buy corn so that they can produce ethanol. However, the USDA, and then in conjunction, the federal government in the US may introduce certain regulations which will tie carbon intensities associated with certain crops like corn. And if the carbon intensities, and by the way, just to put it out there, what a carbon intensity is the total amount of carbon dioxide that's produced in the production of a certain commodity, such as corn. So if those CI numbers are too high, then what that does essentially is that it makes it inefficient for the ethanol producers to buy that corn. So they will look for corn which is not as carbon intensive. They will look for cheaper corn, and what that can do is that can sort of impact the demand for the corn producers. So again, that's essentially the idea. So there you can think of, okay, what would happen to the price of corn if 20% of the market just disappears, right? So that's essentially what the equilibrium displacement model was trying to analyze. So the difference now with the GEDM, as we'll get to in a second here, is that the EDM is a single commodity analysis, right? So that's essentially, let me just go to my tools here. Um, yeah, I guess I didn't have to do that. Was that the one that I was using? Okay, perfect. So the idea basically was that if there is a sudden change in the market, whether it's a demand or a supply shock, what happens to the price? And typically, to find that, what you need are elasticities. So elasticities are, again, something that we talked about and we've already done sort of like an assignment on it. The idea that if your price changes, what happens to the demand in the commodity, or what happens to the supply of that commodity, right? So those are some measures that we already know, and then we can utilize those elasticity figures to compute what the percentage change in prices are, right? So we looked at this. So we looked at a model such as this right here. And then we're just trying to understand that, let's say for some reason, supply decreases from S naught to S1. This was the equilibrium point originally. Now we are moving to this point here. what essentially is the change in the price because of it, right? So what the idea is that to sort of make that determination, what you can clearly see is that the percentage change in quantity demanded has to equal the percentage change in quantity supplied. If you have that, if you know that by association to be true, you can then equate those two equations to compute the percentage change in price. That's essentially what we try to do here. So this is sort of like the main equation that we were dealing with right here. So the percentage change in quantity demanded should equal the elasticity of demand times the percentage change in price times the shock. Now this right here, the genesis of this formula, and I don't think I talked about this in the previous sort of uh, lecture on EDMs, but it's a very sort of straightforward idea that comes from elasticity. So what is an elasticity? I hope by now you sort of understand this is the change in demand equaling the change in quantity. And then that is, of course, driven by the change in price. And then this is nothing but this right here. So this essentially is the formula. And you can convert this into percentage terms. So this is nothing but the percentage change in quantity over the percentage change in price. So this relationship essentially holds true, right? So how do we use this to get to this, right? So all this essentially is, and hopefully there is a here. So, oh boy, let me just delete that. Okay. So when I sort of manipulate this equation here, I basically get a percentage change. Okay, so let me write that down again. Percentage change in quantity of demand equaling, so I just cross multiply, elasticity of demand times the percentage change in price. So that's how we get to that point. And then you can do something very similar for the percentage change in quantity supplied, which is nothing but elasticity of supply times the percentage change in price. So again, the common thing being that the percentage change in price is essentially common. And then here we also know that these two to be equal. So how are we modifying these two things to get to this system down here, the EDM system as we call it? Well, it's fairly straightforward, right? So we have a percentage change in quantity demanded, and now I'm arbitrarily imposing that suppose there is a supply shock, or suppose there's a shock in the market. So if there's a shock in the demand, we just do SD, and this could be a positive shock or a negative shock. So, you could be a producer in the corn market, and there could be a situation which sort of, increases your demand or decreases your demand. So that's a shock in the market. Similarly, there could be a shock in the supply market, right? So suppose there's flooding. So if you have been following the news, this past sort of fall, there was a massive flooding in the Alberta area, which is in upper sort of prairies part of Canada, and they lost their whole bunch of commodity because it was massive flooding, and whole sort of swaths of land were just wasted away. And so, their whole wheat crop got decimated. So that would be an example of a supply shock, basically. So you have sort of these two things, and we know that, you can equate these two, and then you can solve for this percentage change in price. So we already sort of talked about this, and we got this sort of formula, and you have already used this formula to complete the previous assignment, right? So that was essentially what EDMs were about. Then we looked at this example, we sort of solved that. Now, what I want to do is I want to move on to generalized equilibrium, what is known as a GEDM. So you already know what an EDM is. Now we want to talk about GEDM. Let me go here on that. We can delete that, perfect. Okay, so what is a GEDM? Well, the idea with the GEDM is you want to incorporate the effect of what happens in one market onto another. And this is a fairly common problem, and which is why I really need you to sort of pay attention and try and re-watch or re-listen to what I'm going to say in the following few minutes. Okay. The idea is that you have to worry about not just one market, you have to start thinking about others. Okay. So even though we have an example of apples and pears here, uh, the more classical example, the one that I deal in with most, at least in my own research, is the relationship between the top three grains. So the relationships between corn, soybean. So this is sort of like the classical one because you have a lot of sort of substitution that happens between corn and soybean. And then, of course, there's substitutions that'll happen between corn and wheat or corn and soybean, right? So the point I'm trying to make here is I suppose there is a shock in the corn market as we looked at in the past. So that was what EDM was about. Suppose there's a shock in the corn market. I want to look at the impact, not only what happens to the price of corn in because of the shock in the corn market, but what also happens in the wheat market. And that's essentially what we're trying to do here. So this is where I really need you to sort of pay attention because some of the stuff is just obvious, right? I mean, this is like one market. So this is the market in apples. And now we're going to have that second market. So you already know what that equation looks like, except there is this secondary term which sort of tries to look at what is the impact and the demand for apples as the price of pear changes. Okay. And here you have a shock of demand in apples. Okay. So that's where sort of like that extra aspect comes into play. Okay. So we're going to walk through this here, and it's not that complicated, but it's important to sort of like pay attention to this. Okay. So again, the idea simply is, let's say there's a shock in the apples market. How does that impact the pears market? That's essentially what I'm trying to do. Because in general, in life, that often is the case. So let me give you an example just from an intuitive perspective. Let's say for some reason, the supply of apples completely crashes, right? So there's just like literally no. Okay, let me just use demand as an example because we're going to be using demand. So let's say for some reason the demand for apples completely crashes, right? I mean, people have just refused to eat apples anymore for whatever reason. Maybe there's a disease going on. Maybe some health study came out that says that apples are not good for you. So the demand for apples completely crashes. So now you can think of the obvious stuff. So if nobody wants to buy apples, well, what will happen to the price of apples? Well, the obvious intuition is the price of apple is going to crash. And that's essentially what EDM is about, the previous stuff that we did. We know intuitively that the price of Apple is going to crash, but we want to compute quantitatively how much that impact is. Okay. However, what will also happen are secondary effects. So if nobody's eating apples, well, they got to be eating some kind of fruit. And here in our example, we're saying that that fruit is pears. So typically, depending on how these elasticities operate, and we're going to talk about cross-price elasticities in just a sec here, even though you already know what those are, we're going to see some sort of impact on the price of pears. Maybe it's possible that just because nobody wants to eat apples, everybody wants to eat pears now. Well, if there is sort of a concurrent demand shock, which is basically a rampant increase in demand for pears, well, that's going to affect the price of pears. Okay, so intuitively, everybody abandoned apples. Now everybody wants to eat pears. Well, if everyone's going to eat pears, then that's going to have a response in their pricing. Okay, and that's essentially what we want to compute. So basically, because there's four equations, it's very difficult to sort of create this formula that you can directly use. What you'll have to do is you'll have to manually compute some of these changes, and which is why it's good to sort of do things just from an algebraic standpoint, just so that you don't have to just rely on a formula. So again, this is the part where it does get a bit tricky. So if you're somebody who was struggling with how to compute those algebraic equations, you're going to have to spend some time thinking about as to how you're going to approach this. I'm going to walk you through it, but just the actual calculations, you will have to just sit down with your pen and paper and try to figure this out. Okay, it shouldn't be that complicated, but if you're somebody who's just struggling with the algebra aspect of it, you'll have to spend some additional time. Okay, not that big of a deal, but certainly not as easily addressed. Okay, so we know that in equilibrium, the percentage change in quantity supplied of apples must be equal to the percentage change in quantity demanded for apples, and the same is true for pears. Okay, so for each relationship, you can solve for the percentage change in apples and the percentage change in pears, respectively. Okay, so you plug in the numbers, you're going to get one relationship from the first equation, from the first market, and then you're going to get another relationship from the second market. Okay, so we go down here, and then when you have two equations and two unknowns, you can solve those two equations, and you can first calculate the percentage change in price of apples, and then a percentage change in the price of pears. Okay, having both the percentage change in prices of apples and pears, you can now solve for the percentage change in quantity supplied of apples and the percentage change in quantity demanded for pears. Okay, so that's essentially how those change in quantity demanded things come into play. Okay, but what we want to do is walk you through an example here so that you don't get super confused about this. So what I'm going to do is we have a system here. So I have elasticities given, and then we have some cross price elasticities. Wow, this is really annoying. Okay, let me just go here. Delete that. Go here. Okay. So here we have certain elasticities that are given, and then we also have cross price elasticities. Now, to go back here to try and address what this extra in the system, what this extra elasticity is. Well, what the cross price elasticity essentially is nothing more than the impact of the price of one good going up, resulting in the demand for another good changing. And this is fairly straightforward. So think about this intuitively. Let's say the price of Coca-Cola goes up. And I'm asking you, what happens to the demand of Pepsi if the price of Coca-Cola goes up? Well, pause the video, think about what will happen. So typically what you'll see is if the price of Coca-Cola goes up, well then, because Coca-Cola and Pepsi are such close substitutes, that the demand for Pepsi is actually going to increase, right? So that's the idea. If Coca-Cola gets more expensive, you're like, I'm not drinking Coca-Cola anymore. I'm going to drink more Pepsi. That's sort of like the idea. And that's essentially what this cross price elasticity is trying to capture. If price of pears increases, what happens to the demand for apples? So that number can be quantified and then can be used in this equation. That's essentially all there's to it. Okay, so I'm going to walk you through that sort of whole question, and then we can sort of talk about how everything is working there. Okay, so let's look at what the problem is saying. So sugar can be produced from sugar beets grown in Montana or sugar cane grown in Texas, right? These markets are linked, of course, and so shocks to one market must be analyzed with respect to the other market. Okay, so I know that the elasticity of sugar beets, so that supply is 1.2. The own price elasticity of sugar beets is 0.9, and the elasticity of sugarcane supply is 1.5, and then the own price elasticity of sugarcane demand is -1. The cross price elasticity of sugar beets demand with respect to sugarcane prices, so the beet with respect to cane is 1.2, and then the cross price elasticity of sugarcane with respect to the sugar beet prices is cane to beet is 1.5. So notice how these numbers are positive. Okay, so cross price elasticities, one thing to remember, of course, is that if those numbers are positive, that indicates that those goods essentially are substitutes. Okay, that's essentially the idea. If price of one thing goes up and there is a response in the other commodity in a positive directions, that means those goods are substitutes. Okay, if those are negative, if that number was negative, then you would think that those are complementary goods. And that, of course, is quite often the case with certain types of products. For example, what is the relationship between coffee and sugar, right? So if coffee gets more expensive, then you can expect that the demand for sugar is actually going to fall, and then vice versa, because coffee and sugar are consumed together. I know you can say, okay, not everybody has sugar with their coffee, but you get the general idea. Okay, so what I'm going to do, and what you have to do with these kind of problems, is you have to think of both the markets. So the market for sugar beets and then the market for sugar cane. Okay, so let's just go ahead and set up our market, and then we have to look at, okay, what are we analyzing? Okay, so suppose I'm saying that the sugarcane supply increases by 25%. Okay, then you could have scenarios where the FDA restricts only Roundup Ready sugar beets to be planted, increasing the demand for beets by 5%. Okay, and then the prices of sugar beets fall by $5 over ton from the original price of $1.50 over ton. Okay, so we'll get to like the third scenario in a second here, but like the first two are essentially where you have those supply and demand shocks. So we want to set up the market. Okay, so let's just go here. Let me see if we have enough space. Okay, we don't necessarily have enough space here. So what I want to do is open up a Word document. Close this, don't save. Copy this. New document, copy paste that. Okay. So we go here. Let me just put some labels here so that it's not confusing. Okay, go back up here. Okay. And okay, so those are those, and that is that. Okay, let me just go here and let me share the screen with you guys. So I go share, window, and then this. Okay, so hopefully you can see that. So this is essentially what is provided to us. And we're going to create two markets. Okay, so we're going to have the market for beets and we're going to have the market for sugarcane supply. So let me just see here, draw. So we're going to use this. And what is the, okay, black is fine. And I can come here. Okay, perfect. So let's just do percentage change in quantity supplied of beets equal to the elasticity of supplied. So now you have to remember that you can't just make it elasticity of supply because there's two markets now. So make sure you actually label stuff. So I'm just going to use B for beets and then C for canes times the percentage change in price for beets, and then plus whatever the supply shock is for beets. So that's SB. Now we can do the same thing for demand for beets. Percentage change, elasticity of demand, and then beets, percentage change, price of beets, plus if there is a certain shock, okay? And the other thing you have to remember now is essentially the cross price elasticity, right? So this is where you have to be a bit careful, okay? So we're gonna add the cross price elasticity in a second here, but I'm also going to include, of course, the shock in the demand for beats. Okay, so if you don't think about the cross price elasticity term, this market is essentially what the EDM is. So the single commodity analysis that you have already done is what this looks like. The only sort of addition that you see here is that shock, right? That's essentially what we're trying to understand. So typically, the response usually is going through the demand side. You could sort of analyze the cross price effects in the quantity supplied as well, but usually the markets are related with each other because of the way consumers respond. Okay, so it actually makes a lot of sense to have the cross price elasticity term in the demand equation. Okay, so let me just go here for a second. Okay, so scrolling, make sure I have the correct equations for sugarcane and beets. I go up here. Okay, so let me go back here. So basically, we are trying to understand what happens to the elasticity of demand for beets as the price of cane increases. Okay, so what happens to the quantity demanded of beets as the price of cane increases? Okay, so this is essentially uh, what will be given. And you can actually see it's given right here. So if you look at 0.5, that's what that cross price elasticity is. Okay, the cross price elasticity of sugar beets demand, so notice demand, D, with respect to sugar cane prices. Okay, so that's essentially what that 1.2 is. Okay, however, please don't forget the other thing that goes with it, and that is the percentage change in the price of the other good. Okay, so most people just put this in and then they forget what the other thing here is. So notice how this is the percentage change in beets, but now this will be multiplied with the percentage change in the price of cane. Okay, so that's something to essentially consider when you are setting up the system. Okay, now, even though this is not mentioned in the notes, I would like to give you a brief background into why this term is basically being added to this, right? So if you look at what the cross price elasticities are, the cross price elasticity, so let's say we're trying to figure out the cross price elasticity of demand for beets to cane, okay, the term that is here. This is nothing but the percentage change in quantity demanded of beets. So percentage change, so this is QD beets over the percentage change of quantity demanded, the percentage change of the price in cane. Okay, so C. So that's essentially what the cross price effect is. The price of cane goes up, and you're trying to figure out what the response and the demand for the beets is. Now, if you cross multiply, you will realize that this is nothing but the percentage change in quantity demanded for beets equaling the EDBC times the percentage change in the price of C. And that right here, this right here, is essentially why you have this term here. Because not only are we thinking about the own price effect, so when the price of, let's say, beets changes, it has an impact on its own price, but then we are saying that, okay, what happens to the demand of beets when something else's price changes? So that's why you have that extra term. And then, of course, this is the shock term, which was also present in the EDM. Okay, so that's essentially that one market for beets that we have. And now what we want to do is that we want to set up the second market. So it's the exact same idea. So if you want to pause, you can go ahead and pause the video and set up the second market on your own. And again, you can refer to the notes. Essentially, in the example that we just looked at, we have apples and pears. Now you have the exact same thing, except we have canes and sugar beets. Okay, so let me just set up the next market here. So this was, of course, market one. I don't know if my eraser is going to work here. Okay, it probably will. Let me just delete this for a second. Okay, perfect. Okay, so percentage change in quantity supplied of canes, which is C, is nothing but the elasticity of canes times the change in the price of canes plus the supply of canes. So the supply shock in cane. And then similar to the previous case, you have the quantity demanded of the percentage change in quantity demanded of canes equals the percentage change in elasticity of demand times the percentage change in the price of cane. And then comes that cross price term. So you're going to have the elasticity of demand. And this is this one right here. So what happens to the demand for cane as the price of beets changes? So then again, in brackets, you're going to have cane comma B. Notice it's the opposite from what we had before, times what the percentage change. Okay, that's a typo. What the percentage change percentage change in the price of beets is, plus the shock in demand for cane this time. Okay, so now you have this. That's your whole market. That's it. You're pretty much done. All you have to do is plug in the numbers. The stuff that is not available to you, you just solve for it. And please remember that these two equations are equal to each other. So all you have to do, you have to set this equation equal to this equation. So let me use a different color. So with green, you have to set this equation equal to this equation. And then let me use this color. You have to set this equation equal to this equation. And wow, that's a super funky color. I think it's some sort of space color. Okay, and that's pretty much it. You get those things, you're going to plug in the numbers, and then you're going to solve those two equations. Okay, so this is where sort of your algebra skills are going to come in handy. So I'm going to go ahead and just start plugging some numbers here, because notice that the first sort of market is fairly straightforward. So let me just, what is the elasticity of supply with respect to beets? So this right here. Okay, so this is just, let me use black again. So this is elasticity of supply in terms of beets. This is the own price elasticity of demand for beets. So ES, ES, dB. Okay. What is the elasticity of sugarcane supply? That's for the next equation. And then we already know what the cross price elasticity is. And that's all there is to it. Okay. So we go up here. That is 1.2. So 1.2 times the percentage change in the price of beets. So we don't know that. We're trying to figure that out. So that's percentage plus the shock in supply for beets. We'll sort of look at the system and determine whether there's a shock or not. Equal, because remember, the green equations are equal. The elasticity of demand for beets, which we know is negative 0.9. So we go here, that's negative 0.9 times the percentage change in the price of beets, which of course is what we're trying to figure out. So percentage change in the, okay, that's typo. In the price of beets. And then we have the cross price term. It's just this term right here. So what is the cross price elasticity? Well, we already talked about it. The cross price elasticity is 1.2. So 1.2 times the percentage change in the price of C. So again, this is something that we're also trying to figure out. We don't know what that is. And then whatever the shock in demand for beats is. Okay, so that'll just be your first market. So first market, and this was of course the market for beats. Now you have the second market, which is the market for cane, and you do the exact same thing. You equalize these two lines with the space coloring here, star coloring or whatever you want to call it. So now we just look at for this one. So let's look at what the elasticity of supply for sugarcane is. Well, it is 1.5. So 1.5 times the percentage change in the price of canes. So the percentage change in the price of canes plus the shock in supply of the canes. Okay. And then you have the other side. What is the elasticity of demand for cane? It is -1. So again, this right here. So this was the, let me just label that for you as well. So the elasticity of supply for cane, so this was that. This is the elasticity of demand for cane. And then, of course, 0.6 was that cross price term. So negative, so 1.5 and then -1. So we have -1 times percentage price of cane plus the cross price term is 1.5. 1.5 percentage change in price of beats. Okay, not cane. Cane's already used, plus whatever the shock and demand for cane is. So that's basically your setup. And now you have to find out the change in those prices. Well, the one thing that you may ask yourself now is that, well, wait, what about these supply shocks and demand and supply? What's going on with these? Well, again, now you have to just look at the question. What was the question originally asking you? So I'm going to go ahead and switch back to my PDF for a second here. So I go here, I have window. Let me just go back here. And you'll see that in the question that we were doing, the question saying analyze sugarcane supply, and then I'm just sort of trying to understand what happens in the prices if sugarcane supply increases by 25%. Okay, so the sugarcane supply is increasing by 25%. That means there's a shock in the supply market for sugarcane. Okay, so going back to our Word document here. So let me just share this document right here. Okay, so going back here, I'm saying that in the sugarcane market, there's a shock in supply and there's an increase of 25%. Okay, so that's what the shock is. So all I do now is I just replace this right here. So this right here with 0.25. That's essentially what that is. So let me just go here and do this. Okay, so I'm going to replace this with 0.25. Okay, and what happens to all the other sort of shocks in demand and supply? Well, those are just zero because no information is provided about those. So those basically go away. There's nothing provided, and you're basically left with this. So all I'm asking you now is solve for the percentage change in price and solve for the percentage change in price for beets and canes. So that's all there's left. Now for convenience, what I do is that because these are just nothing but X's and Y's, I'm going to replace, so let me just use my pen here. So I'm going to replace the percentage change in price of B as X. And then I'm going to call the percentage change in price of cane, oh, that's a weird C, as Y. Okay, so what does that now look like? So we're just left with 1.2x, which equals 0.9x plus 1.2y. And then, so this is just the first market. So the first market is just this equation. So it's right here. And then the second market is let me just use implied for clarity, 1.5 percentage change in cane. So that is, of course, y equals, okay, not equals, because I have a 0.25 here as well. So don't forget that. So plus 0.25. And that equals negative 0.9, I beg your pardon, negative 1 times the change in price. So negative 1 times anything is just negative that thing. So it's just negative y, okay, plus 1.5. I just want to make sure that my cross price elasticities are correct just one more time in case I'm making some typos. And no, I'm not. Those elasticities are in fact correct. And then you have 1.5x. So again, this market, let me just use a different color. This market that we just sort of set up. Whoa, that is super weird green line. This market that we just set up, I'm just saying that I'm calling the percentage change in price of B, this right here, I'm calling this as X. So let me just highlight all wherever this X is present. So there's X present here, and then there's this X present here. Okay, so this green are these green circles I'm calling as X. Okay, and it's just for convenience. I mean, I don't have to do it because, you know, I can just do this directly, but it's just easier when you convert stuff to X's and Y's to actually solve for them. And then the Y's are just this. This whole thing is just a Y right here. Okay, that's all that is to it. So I go back here and now you can solve. Like, I mean, you can solve this whichever way you're comfortable solving this, right? So I have my certain ways. Whichever way you are comfortable doing this is the best way to just do this. Okay, so let's just go ahead. Again, I'm solving for X and Y. This, again, is like 8th grade math. So I would encourage you to review this. It shouldn't be that complicated, but, you know, in case you have forgotten since those times. So yeah, so this is from equation 1 is just nothing but 2.1x equals 1.2y. So I just brought this x term to this side, so added 0.9x on both sides. So that's how I got this. Okay, and then in this side, what you basically have is, let me just see here. So we have 2.5y because I brought the y to this side, and 1.5x minus 0.25. And now you can just basically solve for y here. So this is y equals 1.5x minus 0.25 over 2.5. And then this y, which you basically got from the second equation. So this is the second equation. You can plug into the first equation. So this y, I'm going to go ahead and plug in here. So let me again scroll down further. Insert blank page. I have no idea why there's a. Okay. So I'm going to use this y and I'm going to plug it into the original equation. So 2, okay, draw. What is even the problem here? It's not drawing. Okay, 2 0.1x equals 1.2 times 1.5x minus 0.25 over 2.5. Okay, so again, now you're just left with solving for x, so fairly straightforward. I'm going to just go ahead and take the 2.5 to the other side, so that's 2.5x. Okay, my x and my multiplications look super jarring, so just keep that in mind. This is an x, and this is a multiplication, so just keep that in mind. And then on this side, we just have 1.2 times 1.5x minus 0.25 times 1.2. Okay, so yeah, go ahead and take the x to this side. So 2.1 times 2.5 minus 1.2 times 1.5, and that's x on this side. And then this is negative 0.25 times 1.2. Okay, so I'm going to just use my Google calculator to speed things up here. So 2.1, let me just use this directly, 0.25 times 1.2, and then divided by 2.1 times 2.5 minus 1.2 times 1.5. Okay, so that comes out to negative. So this implies x equals negative 0.089. Let me double check that. Oh, 69, not 89. Go here, raise 869, which of course is nothing but 8.69% in the negative. Don't forget the negative. Okay, so that is x. So what was our x? What we define x as? Our x was nothing but our percentage change in the price for beats. Okay, that is what we're getting for the x. And then what is our y? So our y is, so again, once you solve for x, you can just plug in into this equation. It's just more convenient. You can just plug it into this equation. So let me just go here. And so 2.1 times 8.69, or let me just use the actual decimal values for clarity. Go here. And negative 0.0869. And then you just divide through. Just divide through by 1.2. So this will be your y, which is nothing but your percentage change in C. So when I solve this, this will also be a negative number. So 2.1 into the answer divided by 1.2, which is negative 0.152. So I go here. So y equals negative 0.152. Okay, so that is nothing but negative 15.2%. Okay. So those essentially are your price changes. And let's talk about the intuition here. What essentially is the intuition? Well, the obvious intuition here is that as the supply increases, the price of the cane itself is actually coming down. So the price of the sugar cane is coming down. But because of the way the cross price elasticities are working, the price of beets is also coming down. Okay, so that's essentially what the function of those elasticities is doing. Okay, so and this is fairly common, right? I mean, you're going to have a scenario where uh, supply of something increases, it pulls down one market, and then it can pull down another market as well. Okay, so our analysis shows that because that there's a supply increase in the price of beets, in the price of there's a supply increase in cane. Not only does that bring the cane market down, it is also bringing the beets market down. Okay, so because they're close substitutes, that's what's essentially driving that relationship together, and that can quite often happen, in corn and soybean markets and any other such related markets. Okay, so I'm going to go ahead and put these notes up. You're going to probably have some questions. You're just going to go ahead and struggle a bit, but I would encourage you to work through the problem that I just did on your own. And what I'm going to do is I'm going to leave part 2. The FDA restricts only non-Roundup Ready sugar beets to be planted, increases demand for beets by 5%. This is to do for you, and then you will be sort of, try to do this. In fact, let me just make this as sort of like a required assignment, so that it's just sort of like part of the lecture that you just did. Okay. Let me just go here, and yeah. Okay. I'm going to upload this, and I'm going to upload the lecture. Let me know if you have any questions, and then the full sort of, official assignment is forthcoming, and then we'll take it from there. Okay, thank you.